stars cannot shine without darkness. So if there is darkness around you, then you are a star who need to shine to break that darkness. And don't worry about the darkness, because it is that darkness which is bringing out the best in you. And the darkness which our channel was facing is now ended, and now we are going to start a new series in our channel. Okay, so after a long gap, your math facilitator Divya is with you to help you out in your success. So as a part of this, and we are going to start with the very first topic of proof of irrational numbers, which is usually either a short answer or a essay question. So short answer and essay question, there are different models here um, in this topic, proof of irrational numbers. So we will be discussing those models. And before I start the session, let me thank you all for the amazing 1 lakh subscribers. You have been trusting the channel, and you have been waiting for us to do more and more important videos for you. So here we are, with lot of new ideas and lot of new content and lot more to help you out in your studies. So let's get started. So as I told you, we are going to discuss the proof of irrational numbers, and I'm going to give you the best and the most easiest method to deal with these questions. These are, lengthy questions. Okay, how to prove root 2 is irrational? Question mark. How to prove root 3 is irrational? Root 5, root 7, root 2 plus root 3, root 5 plus root 3, root 3 minus root 7. So all these questions, okay, are a part of your essay questions. How to prove 1 by root 2 is irrational. If this is given for a short, I'll tell you how to write. And if it is given for an essay question, I'll tell you how to write. And 1 by 2 root 3 is an irrational. 3 plus 2 root 2 is irrational. So lot many models. So I will here segregate the proof of irrational numbers topic into different models, which will help you out and make your concept very easier. And after this session, you're never going to forget proof of irrational numbers. So trust me. So short answer or essay, one shot. Sometimes you may get to see in your question paper. So on a whole, it's a very important class for you right now. Okay. So I just want you all to be ready with your pen and copy so that you can make a note of the important models I'm teaching you right now. So let's get started. Yeah. So firstly, I'm going to discuss about factors and multiples. Now you might be wondering, when I was talking, I have to talk about the topic of proof of irrational numbers, then from where this topic factors and multiples came. To talk about proof of irrational numbers, people, so this topic is very important. So if you don't know this topic, you will not understand the proof. Okay, so let's discuss this topic, factors and multiples. Suppose if I have a number, say 12, 12 I can write it as 3 fours up. Isn't it? 12 I can write as 3 fours. So each of this 3 and 4 are called factors. 3 and 4 are called factors, and 12 is called a multiple. And you know that this particular multiple can be expressed as product of its factors. Okay, so 3 into 4. Or I can write 12 as 3 into some number, or I can write 12 as 4 into some number. What is that some number? I can write this as 3 into 4, or I can write this 4 into 3, right? So basically we are expressing the multiple, okay, we are expressing this particular multiple as product of factors. How are we expressing it? As product of factors. Is this point very clear to each one of you in the session right now? Okay, so yeah, since we have learned about this topic, now let me tell you, we have very important, now this is something which you have to remember. So I'm making the session very, 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 simple and slow so that everyone can understand. Okay. So now, next important point is you have a theorem. What is that theorem? If P divides A square, then P divides A. This is the theorem. If P divides A square, then P divides A. Now here, before I explain you the theorem, let me tell you one more important concept here. So here I can say, since 3 is a factor, 3 is a factor of 12. So can I say 3 divides 12? What is the meaning of divides? It divides 12 exactly. Okay, so 3 fours are 12, or I can say 3 is a factor of 12, or 3 divides 12. Every factor divides that particular number, right? So it's a factor of 12, or it divides 12, or very important relation. Okay, so here it is given P divides A square. That means if I divide A square with P, the answer will be 0. Similarly, then P divides A. That means the answer will be 0. Now, what's the meaning of this? And remember, P is a prime number here. So, suppose P, I am taking it as 2. P is a prime number, I am taking it as 2. Now, A, I will take it as, say, A could be any number, I am taking it as 4. So, let me know what is A square. A square is 8. Now, see, let's check this condition. P divides A square. Okay, in this condition, I can write P is 2 divides A square. A square is 8. Yes, 2 is dividing A square. Then they say that this particular P will also divide A. Did you understand? Okay, if this P is dividing A square, then this P will also divide A. So very clearly I can say, if P is a factor of A square, divides means factor. If P is a factor of A square, then P is also a factor of A. And when you have factors, you can write factors in this way. Okay, you can write the multiple equal to factor, product of the factors. Is this clear till here? Okay, so let's take the very first question. Proof root 2 is irrational. Okay, you need to prove root 2 is irrational. To prove this root 2 as irrational, we will firstly take root 2 as rational. Okay, so we are taking the method of contradiction here. We are contradicting. Okay, the statement given, you have to prove root 2 is irrational. I'm assuming. So to prove this as irrational, what am I doing? I'm assuming root 2 as rational. Now this is the step which is same to all the models, and as of now we are discussing the very first model. Okay. Now you know very clearly what is a rational number. Rational number can be written in the form of A by B. In the form of A by B. And you very well know A and B are co-prime numbers. What are A and B? A comma B are, they belong to integer and B is not equal to 0, and also A comma B are co-prime numbers. Okay, so here actually some schools give you that A and B are getting cancelled and you get C and D which are co-prime. You can write that step if you want. Otherwise here itself directly you can write A and B, you are taking them as co-prime number. Now here comes the question, what is co-prime? Co-prime numbers are those numbers which do not have any common factor other than 1. For example, 2 by 3. 2 by 3 is like A and B, A by B, where these are co-prime numbers, which means I cannot cancel it further. Cancelling is not allowed because there is no common factor. Okay. And let me take 4 by 5. 4 by 5 is also co-prime because I cannot cancel it further. Cancelling is not allowed because there is no common factor. So A and B are such numbers, okay, they are co-prime, where they don't have any other common factor other than 1. Clear till here? Okay, so which means I cannot cancel it further. No common factor. I'm saying no common factor. Clear? So remember this point. Now just see. So we have assumed root 2 is rational and I have written root 2 as root 2 equals to a by b, where a, b belongs to integers and b is not equal to 0 and a, b are co-prime numbers. Now let me transpose b to the other side, so I get a is equals to root 2b. Now since I cannot do any adjustments here, so once you are at this step, now the next step you have to remember is you need to square. Okay, squaring on both the sides. Squaring on both the sides, it will give you a square is equals to 2b square. A square is equals to 2b square. Okay, or a square is equals to, I can write this as 2 times b square. A square is equals to 2 times b square, right? So here, therefore, I can say a square I am able to write it as 2 into b square. A square I am able to write it as 2 into b square. So therefore, can I say 2 divides a square? How am I saying this? Because see here, I wrote 12 is 3 into 4. So I am able to say 3 divides 12 because 3 is a factor. Okay, so when you are able to express this as a product of any two numbers, then I can say this particular number divides the number on the LHS on the multiple. Okay, here this is a multiple actually. Okay, now you understand why did we discuss the first concept? Okay, so I am saying 2 divides a square. Now from the theorem, see, if p divides a square, then p also divides a. So here 2 is dividing a square, so therefore can I say 2 also divides whom? 2 also divides a. Okay, so when 2 is dividing a, can I write a is equals to 2 into some constant? See here. Now when 3 is dividing 12, which means 3 is a factor of 12. So I can write 12 is equals to 3 into some number. That's what we discussed. 3 into some number. So here also the same. So 2 is dividing a. So I can write a is equals to 2 into c. 3 is dividing 12. So I can write 12 equal to 3 into some factor. Are you able to understand? So 2 also divides a, which means I can write a equal to 2 into some number. Now have a look here. So here, this is what I got. So I got a is equals to 2c. So let me substitute this a equal to 2c in this particular equation, where anywhere here you can substitute. Okay, so substitute a equals to 2c in equation 1. So what do you get? A is 2c whole square is equal to 2 into b square. Here in the place of a, I substituted 2c. So 2c whole square equal to 2b square. So I get 4c square is equals to 2b square. So I get b square is equal to 4c square divided by 2. 2 is in multiplication, sending to other side becomes division. So I get 2c square. So I got b square is equal to 2 into c square. Or can I say b square equal to 2 into, so 2 into something. So can I say this 2 divides b square? Are you able to understand? So when you are expressing it as products, so this number will divide this. Okay, so therefore 2 divides b square. And from the theorem, we know 2 also divides whom? 2 also divides b. So when 2 is dividing b, I can write b is equals to 2 into some constant. Are you able to get? Okay, so here I have written a is equal to 2 into some constant. Okay, and I am also able to write b is 2 into some constant, which means this 2 is actually the common factor. What is 2? Therefore, 2 is a common factor. It is a common factor for a and b. But the very first condition you have taken is a and b are what? Co-prime numbers. So I told you there are no common factors for co-prime numbers. So therefore, we have arrived at a wrong conclusion. Okay, you have taken a and b as co-prime, but then after solving you arrived that a and b have a common factor, which is wrong. Right? Common factor other than 1. 2 is a common factor, which is wrong. So therefore, we have arrived at this step because our first step was wrong. What was our first step? This one. Assuming root 2 as rational was wrong. So therefore, our assumption is wrong and we conclude that root 2 is Irrational. Is this very clear to each and everyone? Each and every step you need to understand before you try to, recreate by yourself, or you don't by heart it. Please understand each and every step. Why are we doing it? Okay. So this is root 2 is irrational. Now this model, okay, I will explain with root 5 in a very shortcut way. The steps are same. The steps are same, but I'm going to give you in a very shortcut way so that you can remember it better. So what is the first thing we are doing? All these are same models, root 2, root 5. Okay. So first step is you assume that root 5 is irrational number. Okay. So assume root 5 is rational number. Sorry. You assume it rational number. So when it is rational, root 5 is equals to a by b, where a and b are co-prime numbers. So till here is it clear? And you can write b root 5 is equals to a. After that, okay, after that what do? We just square, because here you cannot do anything. Squaring, you will get root 5 as 5. So you can write this as 5b square equals to a square, and then I can write a square. See, I can write 5 divides a square. So when 5 divides a square, 5 also divides a. Understood? 5 divides a square, then 5 also divides a. Give me a second. So I'm writing 5 divides a square, because I'm able to write a square is 5 into b square. So 5 also divides a. When 5 divides a, I can write a equal to 5 into c. So substituting this a equal to 5 into c in this equation. So I have 5b square is equals to a is nothing but 5 into c whole square I have. So 5b square equal to 25c square, or b square equal to 25c square by 5. So 5 one time, 5 times. So I get b square equal to 5c square. Again, this is like same, this relation. So therefore I can say 5 divides whom? 5 divides b square. So when 5 divides b square, 5 also divides b. So 5 divides a, 5 divides b. So therefore 5 is a common factor. Okay, 5 is a common factor for a and b. So therefore I can conclude that our assumption is wrong. Root 5 is irrational. Okay, these simple steps, if you are able to understand and remember, you can do any model question. Okay, root 7 you can prove, root 11, root 3, everything the same steps. Only thing that changes is if I have to prove root 3, in the question they give you root 3. So in the answer also you get 3. Here also you write 3. All the place wherever you find 5, it is 3. Okay, if you have to prove root 3, all the places are 3. Instead of 5, what do you write? 3. Understood? Just you write 3. Here, square it is 5 square. So 3 square will be 9. Okay, so here again you get what? 3. Instead of 25, you will get 9. Here you will get 3. All 3's. Is it clear? Suppose if I want to prove root 11, then instead of 5 here in this question, you will write 11, 11, 11, 11, 11. Is it clear? So the same steps, same model, whatever number is given. So here 2 is given, so you have 2 all over. If you just check 2 all over, and when it is a square, you got 4. When it is 5, you have 5 all over. When it is a square, you got 25. If it is 3, you will have 3 all over, and 3 square will be 9. Okay, so this is the first model which you have to learn. Now let's proceed to the second model. I hope first model is very clear for you. So let's proceed to the second model. First two models are essay questions. Okay, this is the first model. So once you know how to prove this, root 11, root 3, root 7, root of any prime number is the same model, first model. Now the second model, you see. So in the second model, we are discussing irrational number plus or minus irrational number. This is the second model. What does it mean? Suppose I have root 3 plus root 5, which means two irrational numbers are added. Or suppose if I have root 5 minus root 2, two irrational numbers, there is a subtraction. So two irrational numbers, if there is addition or subtraction in between the two irrational numbers, it comes under model Understood? So two irrational numbers, if they are added, or two irrational numbers if they are subtracted, they come under this model too. So let me explain you this in detail. So I'm just taking this as a first model, okay? First example of this model. So root 3 plus root 5, I have to prove it is irrational number, okay? Prove that root 3 plus root 5 is irrational. So how do we prove this? How do we prove this? To prove this, what do we do now? First step I told you. What is the first step always? Assume. What is the first step? Assume. So what are we assuming? Assume root 3 plus root 5 is equals to a rational number. Okay, we are assuming it is a rational number. So when it is a rational number, second step, it is in the form of a by b, where a comma b belongs to integers and b not equal to 0. Some school teachers ask you to write it as p by q. No problem, yeah. You can take rational number as in the variable can be anything. You can take it as a by b, you can take it as p by q, you can take it as r by s, you can take it as c by d. No problem. The condition is a and b should belong to integer and b not equal to 0, the denominator. Here you will write p and q belongs to integer and the denominator not equal to 0. Anywhere the condition is same, depending on the variables, you will write the condition. Is it clear? Okay, so there is no rule that you have to take only P and Q or A and B, it's your wish. Okay, so now see. So I have taken this. Now the next step is here on the RHS you have two irrational numbers, root 3 and root 5. So I will take root 5 is equals to A by B minus root 3. So one irrational number I am transposing to the other side. What am I doing? One irrational number I am transposing to the other side. After doing this, you don't have any more step to do. So you will simply square it. Okay, you will simply square. So squaring on both sides. Squaring on both sides, you will get root 5 whole square is 5 is equals to a by b minus root 3 the whole square. Or let me write one more step. So that is equal to root 5 whole square is 5. So 5 is equals to a by b minus root 3 whole square. So this is like a minus b whole square. So a square, in the place of a, I have a by b. This is b square. Okay, so a square plus b square minus 2ab. Understood? A square plus b square minus 2ab. So that is equals to 5 is equal to this I can write as a square by b square plus root 3 whole square is 3 minus 2 root 3 a by b. How did I write this? 2 root 3 a by b. Now remember one golden rule. Golden rule to prove the proof of irrationality number is always try to bring all the irrational numbers to one side and all the rational numbers to one side. What are we doing? We are going to separate two things. What are the two things? Irrational numbers and rational numbers. Try to bring all irrational numbers on one side and all rational numbers on one side. Okay? Clear? All irrational numbers one side, all rational numbers one side. So that's what we are going to do here. So see here. So here I can see this term very clearly. This term is a irrational term. So what I'll try to do is all the rational terms I'll take to other side. Okay. So I have 5, 3 I will take to other side. So I'll have minus 3. A square minus b square also becomes minus a square by b square is equals to minus 2 root 3 a by b. Or you may say, ma'am, this is minus 2 root 3. So can we take minus 2 root 3 to the other side? Yes, obviously you can. No problem. Okay. So 5 minus 3 is 2. 2 minus a square by b square is equals to minus 2 root 3 by ab. No harm in solving this. However you want, you can solve. Now I can take LCM. So 2b square minus a square by b square is equals to minus 2 root 3 a by b. Now again the golden rule comes into picture. What did I tell you? All irrational numbers on one side and all rational numbers on one side. So here I can very clearly see now here this is a irrational number. So I'm trying to keep root 3 on one side and a, b, 2, I'll take it to the other side. So I have, see here, let me write this last step again. This is what I have equals to 2b square minus a square by b square. So I am trying to keep root 3 on one side. So this minus 2a by b, I will send it to the other side. So 2b square a square by b square. This becomes b by minus 2a. Okay, minus 2a by b becomes b by minus 2a. Okay, this is the fraction which reciprocals. Is it clear? So 1b gets cancelled. So root 3 is equals to, I have a minus here, I can write it as a square minus 2b square. Okay, taking this minus up, a square minus 2b square by 2ab. Now, see here, it is sorted out. You have separated irrational number one side, rational one side. Now you will write here, what are the terms included? See here, I have a, so I'll write a. I have 2, so write 2. I have b, so write b. Here also 2ab is there. So this 2ab belongs to whom? Integers, isn't it? They belong to integers. You know, ab belongs to integer here and 2 is also belongs to integer. And also 2ab, the denominator is not equal to 0. And also this is in the form of p by q. So I can say this total side is which type of number it is? It is a rational number. Okay, so total your RHS is a rational number and very clearly your LHS is irrational number. So this is a conflict now. You prove that irrational number is equal to rational, which is a conflict. Both are opposite. So therefore, you arrived at this conflict because you have taken your first step as wrong. What is the first step? Root 3 plus root 5 is rational. That is wrong. So therefore, you conclude root 3 plus root 5 is irrational. Did you understand? So always remember rational to rational, irrational to irrational. That is the concept. Okay. So now let me take the second one here. So very quickly I'll explain in a shortcut way. See, this I have to prove is irrational. So what is my first assumption? Assume root 5 minus root 2 is what? Is rational. So when it is rational, you know root 5 minus root 2 equals to a by b, and you know a comma b belongs to integer, a not equal to 0 and a by b are co-prime. So root 5 I will write it as a by b plus root 2. So when two irrational numbers are there, one irrational number, throw it onto the other side. Now once you throw it on the other side, the next step is you square. So squaring on both sides, what do I get? Root 5 whole square is 5 is equals to, this is a plus b whole square formula you will get. So a square plus b square, root 2 whole square is 2 plus 2ab. So 5 equals to a square by b square plus 2 plus, this I can write as 2 root 2 a by b. 2 root 2 a by b. So let me write it here, a by b. Okay. Now the concept, all rational one side, all irrational other side. So I'll write 2 root 2 a by b on one side equal to all this. These two I'll take it to the other side. So I have 5 minus 2 minus a square by b square. Okay. So again 2 root 2 2 root 2 a by b is equals to 5 minus 2 is 3 minus a square by b square. I can also take LCM. So it will be 3b square minus a square by b square. This is what? This is 2 root 2 by AB. I know root 2 is irrational, so root 2 I'll keep it on one side, and 3b square minus a square by b square into this 2a by b fraction becomes b by 2a. So b cancels, so root 2 is equal to 3b square minus a square by 2ab. Now this total is rational, this is irrational, so therefore it's a contradiction. So therefore root 5 minus root 2 is irrational number. So did you all understand? So this is the second method. what are we doing? We are trying to keep all rational one side, all irrational one side, and firstly I sent one irrational number to the other side and I squared it. Once I squared it, my aim is to bring rational one side, irrational to one side. So that's how I am rearranging. Is it clear, everyone? Yes. So third model, ready? Model number 3. Now those two were essay questions. Now these are very simple. Suppose if I have to prove root 2 is irrational. Okay, this model is nothing but proving a rational number into a irrational number. Okay, rational into irrational model. This is okay. This is rational. This is irrational. Okay, so see here. So first step is same. What is the first step? You assume 3 root 2 as rational. Very simple this is. When you assume 3 root 2 as rational, you get 3 root 2 equal to a by b. Here you don't have to square. Okay, when you have two irrational numbers only like this, you square. Okay, or in the first model you square when you have a single irrational number. Here one rational number is helping you, so you don't have to square. Okay, so here what do? The same logic I told you, rationals one side, irrationals one side. So irrational root 2 I am keeping one side. This 3 is rational, so let me send it to the other side. 3 is in multiplication, going it to the other side becomes division. Okay, so this becomes 3 by b. So here this is irrational number. What is this? Rational number. Irrational cannot be equal to rational. So therefore our assumption is wrong and 3 root 2 is a irrational number. Was model 3 very simple? Right? So similarly you can take any question here. Any question. Suppose if I take for example second question as 7 root 2. So you will write 7 root 2 equal to a by b, rational number. You will write root 2 equal to a by 7b. So this is rational, this is irrational. Wasn't it easy? Chalo, model 4. Let's proceed to model 4. So in model 4, you have rational number divided by irrational or irrational number divided by a rational number. Here you have multiplication of rational and irrational. Okay, here you have rational and irrational in division form. For example, 2 by root 3. I have to prove is irrational. Okay, so here also very simple. You will take 2 by root 3. You will assume, okay, assume 2 by root 3 as rational. So when you are assuming this as rational, so 2 by root 3 equal to a by b, or I get 2 equal to root 3 a by b. Now our golden rule, all irrationals one side, rationals one side. So this root 3 is irrational, a by b I will send it to the other side, it becomes b by a. So this is irrational, this is rational. So therefore 2 by root 3 is irrational number. Always never you should get irrational equal to rational. Is it clear? Okay. So if you want to take another question also, you can take, for example, I can take 1 by root 2 also same model. 1 by root 2 equal to, you will take a by b. So root 2 equal to b by a, just reciprocally. So this is rational, this is irrational. So therefore 1 by root 2 is irrational. Okay. This is for short. If it is long, then you will write root 2 equal to b by a, and from here you will try to prove all the model 1. Okay, that you will write entirely root 2 as irrational number, you will prove. That is for long. Okay, so here this is for short. So question number 2. Okay. Now you might be wondering why am I writing this, because I'm going to share the notes with you in Math Facilitator website. As you all, some of you might already know, we always share the notes in Math Facilitator website so that you can download it for free and revise. Okay, so all these notes you will get it for free on Math Facilitator website, so you can revise it from there. Link of Math Facilitator website is in the description, mathfacilitator.com. Even if you type in the Google, you will get. Okay, chalo, this is clear. One more model, let me tell you. One more example. Sorry. So what shall I take? Shall I take root 5 by 2? Okay, is irrational. You have to prove this. So you will take root 5 by 2 is equal to a by b, rational number, and root 5 is equals to 2a by b. So this is rational, this is irrational. So hence it is proved. Is it clear? Okay. So therefore root 5 by 2 is irrational. So this is model number 4. Now let us proceed to model number 5. I am trying to cover as many questions as possible in the same video. Okay, fifth model, you will get rational plus or minus irrational is done, right? I have discussed irrational plus or minus irrational number. So similarly, similar to model 2, you have rational plus or minus irrational, which means rational number plus irrational number you can have, or rational number minus a irrational number. Okay, for example, question like this, 6 plus root 2 is irrational. Suppose if I have to prove this question, how do I prove? So very simple, see here, I will assume 6 plus root 2 is rational number. First step is same for all the models. So 6 plus root 2 becomes a by b, where a, b belong to integer and b not equal to 0. Always remember to write this. Okay, and then the next one, our aim is irrational number one side, rational number other side. So root 2 is irrational one side. So this is 6, isn't it? This is 6. Rational number 6 is rational, so I am sending that to the other side. Okay, this is 6. Now I can take LCM. So very clearly this is rational, this is irrational. Rational equal to irrational can never happen. So therefore 6 plus root 2 is irrational. Is it very simple? Right? So shall we take one more example here? One more. Chalo. So I'm just taking your textbook example. So I have to prove that this is irrational. To prove this as irrational, what I have to do? I have to assume it as rational. So 3 plus 2 root 5 equal to a by b. Now where is the irrational number? Here is the irrational number, isn't it? So this rational, I'll send it to the other side. So I'll have 2 root 5 is equals to a by b minus 3. Or I can write root 5 equal to, let me write one more step. I'm taking LCM here. Now 2 is rational, so send it to the other side. 2 becomes 1 by 2. 1 by 2 into a minus 3b by b. Or the same thing I can write it as a minus 3b by 2b. Clearly this is rational and this is irrational. So therefore this is a irrational number. Is it very clear to everyone? Yes. So what did we do in this model? Rational number on one side, irrational number on one side. That's what we are trying to do. And if the minute you get rational equal to irrational, it is false, and hence you say our assumption is wrong. So this is model number 5. Is it clear? And these are the basic models. So here in division you can also segregate it as this model. This has a separate model like 1 by irrational number. Okay, 1 by irrational number like root 2, 1 by root 3, 1 by root 5, all same model. Okay, so total I have segregated into 5 basic classic models. So let us revise quickly. First model is root of any prime number. I am saying it is irrational number. Okay, root of any prime number, root 2, root 3, root 5, root 7, root 11, any root of any prime number, same model. So for this model, this theorem is important. Okay, and this concept is important. Okay, this box. Is it clear? And then you can solve it. So if I have root 2, I get 2 all over. If I have root 5, I get 5. If I have root 3, I'll get 3. Root 7, then I'll get 7. Same steps. Model number 2, irrational plus or minus irrational. So 2 irrational numbers or 2 irrational numbers in addition or subtraction. If they are in addition or subtraction, what do? You firstly take it as rational number. Okay, then one irrational number you send it to the other side. and then you square. Once you square, this is a minus b whole square formula, expand and you apply the golden rule. What is the golden rule? All rationals one side, all irrationals one side, and hence you get rational equal to irrational, which is false. So the other model also, see here, the second example. So the same thing, you assume it as rational. Okay, one irrational number you will send it to the other side and you will square. After that, the golden rule, all irrationals one side, all rationals one side, and you prove that rational equal to irrational, which is false. Then the next one, here also, third model, rational into irrational. Okay, fourth model is rational divided by irrational or irrational divided by rational. So here product of a rational and irrational, here division of rational and irrational is happening. So when there is a product, you assume the given number equal to rational, okay, and irrational number one side, rational number one side. You are applying the golden rule simply. Here also assume it as rational and then all irrational number one side, rational number one side. Okay. Now model number 5 is rational plus or minus irrational number. So when you have like this rational plus irrational, you assume it as a rational number and then the rational number which you have, you will send it to the other side, irrational number on the one side. So which means again applying the golden rule, all rational numbers one side, all irrational numbers on the other side. Here also you can see, assuming it to a rational number, and this rational term you will send it to the other side, okay, and you get irrational number equal to rational, which is impossible. So therefore you conclude that the given term 3 plus 2 root 5 is irrational. So 5 basic models. Okay, and I have segregated this way so that you can understand when a question is given, which model, which steps you have to write. Okay, so understand when a question is given, immediately analyze. Suppose now I give you a question. Now I say root 5. Immediately you should think at a root of any prime number. So this is the first model. I should write all those steps. If I give you root 3 minus root 2, immediately you have to think, are this is two irrational numbers. Subtraction of two irrational numbers. So this is model 2. And remember, in model 1 and 2 you have squaring. In no other model you will have squaring. Okay, squaring on both the sides, only in model 1 and 2 you do. Okay, when there is a single rational number or two irrational numbers. Single irrational or two irrationals. Now when you have the other models like a product of like this, rational, irrational. So this is model 3. Suppose if I have like this 1 by root 5. So rational divided by irrational. So model 4. Suppose if I have 3 plus 2 root 2. So rational plus irrational. Or if I have 5 minus root 3. Rational minus irrational. So wherever at least one rational number is involved, all these models, okay, all these models have no squaring. Okay, you're not squaring, you're just applying the golden rule. What is the golden rule? Rational numbers one side, irrational numbers one side. In model 2 also you're applying the same golden rule, okay? But you're squaring and then applying the golden rule. So all these models, you have to remember that irrational number one side, rational number one side. Whenever you find at least one rational number in the given question, okay, so you have to think that there is no squaring, and golden rule you will apply. Irrational numbers on one side, rational numbers on the one side. Only the first two models you will square, okay, because you don't find any rational numbers here, all are irrational numbers. Is it clear? Yes. So this is all about proof of irrational numbers, and I hope you have enjoyed the session and now you don't do any mistake in any single question. Okay. So I wish you all subscribe to the channel right now, and if you are still watching the video, which means you have liked my explanation, so definitely like the video right now. And let me tell you, we are going to get so many more important videos like this. Every day you'll have a video, so do share the channel with all your friends right now, and also comment and let me know your suggestions or feedback, or how are you liking the video, or if you need any more extra content or topics you want me to do here. And definitely your comments will give me the feedback of what you want so that I can do it accordingly. Is it clear? So please do like, share, subscribe and comment. So bye bye people, take care. I'll see you all in the next class. Thank you so much for being here.